Welcome to the DIY Honda Garage channel. The DTC P0812 indicates an open in the transmission range switch, ATPR, automatic transmission position range circuit, for the Honda Odyssey models produced between 2011 to 2017. This specific error arises not from mechanical issues within the transmission itself, but rather from an electrical circuit malfunction. The transmission range switch is vital for signaling the current gear position to the vehicle's engine control module, ECM, and is typically located at the transmission housing area. The error code highlights a problem within the switch's circuitry that needs prompt attention. Before starting the troubleshooting, it is imperative to document all freeze-frame data and perform a snapshot using Honda Diagnostic System, HDS. This ensures comprehensive analysis during the diagnosis and aids in effective problem solving. DTC P0812 pertains directly to the automatic transmission position range switch, commonly referred to as the ATPR switch. The primary role of the ATPR switch is to accurately transmit the current gear position of the transmission to the vehicle's engine control module, ECM, which in turn affects engine performance and drivability. This switch is mounted on the transmission housing, making it integral for the overall transmission system functionality. An open circuit in this switch will prevent the ECM from recognizing the correct gear position, leading to malfunctioning or erratic transmission behavior. It is essential to address this error promptly to maintain optimal driving conditions and avoid further complications. There are several potential causes for the DTC P0812 error code. First, an open circuit in the wiring can disrupt the transmission of signals from the ATPR switch to the ECM, resulting in the detection of this error. It is critical to inspect the wiring for any visible signs of wear or damage. Second, the transmission range switch itself may be faulty, which would impair its ability to function correctly. Third, poor electrical connections can also be a significant factor, as corroded or loose connections may impede the electrical flow required for accurate signaling. Identifying the specific cause is key to implementing an effective repair strategy. When the DTC P0812 is present, several symptoms can manifest, leading to noticeable performance issues. The most common symptom is related to the transmission shifting behavior, which may become erratic or unresponsive due to the switch not accurately relaying the gear position. Additionally, the check engine light will likely illuminate on the dashboard, alerting the driver to potential engine management issues. An inaccurate gear display on the dashboard can also occur, confusing the driver about the vehicle's current gear, further complicating operation. Recognizing these signs early can be crucial for timely and effective repairs. The first step in troubleshooting the DTC P0812 involves turning the ignition switch to the on position, designated as position 2. This sets the electrical system for diagnostic testing. The next step requires the driver to shift the transmission into the reverse R position. At this point, utilizing the Honda Diagnostic System HDS is crucial for real-time data monitoring of the ATR switch signal. Technicians must check if the ATR switch is indicating on. If the switch is on, it suggests an intermittent failure, implying that the system is functioning correctly at that moment. However, if the switch does not indicate on, further investigation is warranted by progressing to the next troubleshooting step. In step 2 of the troubleshooting process, the technician must turn the ignition switch to the lock position, which powers down the vehicle systems to ensure safety. Once in the lock position, it is necessary to disconnect the transmission range switch connector. This action isolates the switch from the circuit, allowing for more accurate testing. After disconnection, a jumper wire must be used to connect terminal number 8 of the transmission range switch connector to body ground. This step is critical as it simulates a closed circuit and will help determine if the switch itself is defective or if the issue lies elsewhere in the wiring. Properly executing this step is vital for the subsequent troubleshooting phases. Step 3 resumes with the ignition switch turned to the on position, ensuring that the vehicle's systems are active for diagnostics. Following this, the technician must again check the ATPR switch signal using the HDS. If the signal indicates on after jumpering, it confirms that the switch is functioning correctly and should lead to replacing the transmission range switch as the next step. Conversely, if the signal is still off, further investigation is required to understand the lack of signal. This step essentially determines the fate of the ATPR switch and identifies whether it is the root cause of the DTC P0812, guiding the technician toward the appropriate corrective measures. In Step 4, the technician turns the ignition switch back to the lock position to ensure safety while working on the vehicle's electrical components. The next task is to jump the SCS line using the HDS, which aids in disabling the SRS, supplemental restraint system, to prevent false airbag deployments during testing. Following this, it is essential to disconnect the PCM, Powertrain Control Module Connector, C, which contains multiple pins, including terminal C25. This connector plays a vital role in relaying information between the engine and transmission systems, making it a focal point for troubleshooting. Each of these actions leads to deeper diagnostic insights by isolating the components further in the circuit analysis, setting the stage for checking continuity in the next step. The final step in this troubleshooting process for DTC P0812 requires checking for continuity between PCM connector terminal C25 and body ground. Establishing this continuity is essential as it confirms that the electrical pathway is intact, allowing the transmission range switch to communicate effectively with the PCM. If there is no continuity, it may indicate a wiring fault, which must be repaired to restore proper function. Ensuring good grounding is critical, as poor grounding can lead to a variety of electrical problems, including intermittent signaling issues that could have triggered the original error code. Identifying and rectifying such faults helps ensure that the transmission system operates securely and efficiently. After completing the necessary repairs associated with the DTC P0812, it is crucial to conduct a thorough final verification to ensure that the issue has been resolved. First, the technician should perform a functional test on the newly replaced or repaired transmission range switch, monitoring its performance via the HDS. Secondly, any DTCs present in the system must be cleared, allowing the onboard diagnostic systems to reset and start fresh. Lastly, a road test is essential to confirm that the transmission is shifting smoothly and that the check engine light remains off, certifying that all systems are functioning as intended. Verification not only confirms the success of the repairs, but also enhances the vehicle's reliability. The DTC P0812 refers to a significant issue relative to the transmission range switch circuit, demanding efficient diagnostic measures. Understanding the implications of this error code is critical for mechanics, as it emphasizes the need for addressing electrical rather than mechanical issues. Adopting a systematic approach to troubleshooting allows for clear identification of the problem, ultimately leading to timely and effective solutions. Keeping track of the steps, confirming component functionality, and verifying repairs through testing are all crucial aspects of this process. Lastly, dismissing this error code without comprehensive verification can lead to further complications, underscoring the importance of confirming a successful resolution before concluding the repair process. Please like and subscribe to the channel. See you next time!